Welcome to the video. My name is Pushpinder Gill, and today we are going to learn permutations and combinations. So this is the first video on permutations and combinations. This is my email address here. So in case you want to contact me, you can contact me on the email address. So let's go ahead and get started. Okay, so let's see this simple question over here. David has 3 shirts and 2 sweaters, and how many ways he can either wear a shirt or a sweater, right? So this is a simple question for us. So David has 3 shirts. Let's suppose he has these 3 shirts, and he has 3 sweaters. Let's suppose, 2 sweaters. Let's suppose he has these 2 sweaters. So the question asked is, in how many ways can he either wear a shirt or a sweater? So he can either wear this shirt, or he can wear this shirt, or he can wear this shirt, or he can wear this sweater, or he can wear this sweater. So the number of ways in which he can either wear a shirt or a sweater is 3 plus 2, that is 5 ways. Right? So I hope everyone is understanding. This is simple basic stuff, right? What if I twist the question a little bit? I said David has 3 shirts and 2 sweaters, and how many ways he can either wear he can wear 1 shirt and 1 sweater. So instead of an or, what I've done is I've placed a and, right? So he has to wear 1 shirt and 1 sweater. So how many ways are there? So with this shirt he can wear these 2 sweaters. So 2 ways with 1 shirt, and with this shirt as well, again 2 sweaters, and this shirt as well, again 2 sweaters. So that means the number of ways he can wear either 1 shirt and 1 sweater is 3 into 2, that is 6 ways. Right? So this is simple basic stuff. If you want to wear either a shirt or a sweater, then there are 5 ways, and if he wants to wear a shirt and a sweater, then there are 6 ways. Right? So hope everyone is understanding that if event A can be done in m ways and event B can be done in n ways, then exactly one of the events can be done in m plus n ways. Right? If event A and B together can be done in m into n ways. Right? So I hope everyone is understanding. Till now it's pretty basic stuff. You must be knowing all this even before watching the video. So let's go ahead and get started. So let's see the simple question. Let me say there are these 3 cities: city A, city B, and city C. The number of ways of going from city A to city B are 3. So there are 3 ways by which you can go from city A to city B. And similarly, there are 2 ways by which you can go from city B to city C. Now if I ask you how many number of ways are there to go from city A to city C via B, so you have to go through B. So there are 3 ways here, there are 2 ways here. Yeah, the total number of ways would be 3 into 2, because you have to go through B. So 3 into 2, that is 6 ways. Now let me say there is another city called city D as well, and city D has 4 ways for it to go from city C. So from city C to city D there are 4 ways. Now if I ask you how many number of ways are there to go from city A to city D via B and C, so that would be 3 into 2 into 4, that is 24 ways. Right? So I hope everyone is understanding my point here. What I'm trying to prove, that if event A can be done in m ways and B can be done in n ways, then both the events together can be done in m into n ways. Right? So you understand the logic behind that. Why? Because see, if we, let's suppose, want to go from city A to city C, so 3 ways are here and 2 ways are here. Each way here is gonna give us 2 ways. So 3 ways are going to give us 3 into 2, that is 6 ways. So that is how we calculate the answer. Right? So I hope everyone is understanding. Let's move forward to some complex scenarios. Okay, so in how many different ways can 5 different chocolates can be distributed to 4 children such that any child can get any number of chocolates? Right? I need to do that. Okay, let's see this question, right? So a new flag with vertical stripes is to be designed using some of or all of the colors yellow, green, blue, red, and the number of ways this can be done such that no two adjacent stripes have the same color. So now what kind of question is this? Earlier we were just distributing sweaters and shirts to the students. Now over here there is a condition. So whenever there is a condition, we have to meet the condition. Now he's saying that no two adjacent stripes should have the same color, and there is a flag with 6 vertical stripes. So the flag is gonna look something like this, right? So what in this kind of question, what you have to do is you have to start from anywhere. Let's start right from here. So how many colors can you give this stripe? You can give them either yellow, you can give it either green, you can give it either blue, or you can give it either red. So there are 4 ways in which you can give color to this stripe. Now we have to meet the condition, and the condition is that no two adjacent stripes should have the same color. Now if one color has been given to this stripe, that means this stripe cannot have the color which was given to this stripe. So that means the number of ways which we can give color to this stripe is 3 ways. Right? Now let's look at the next stripe as well. Now in the next stripe, we will be able to give the color that we gave to this stripe, but not the color to this stripe. So let's suppose this was given yellow and this was given red. So now we have a choice of yellow, green and blue from this stripe, because we can already give him yellow, because no two adjacent stripes should have the same color. So again 3 ways. Similarly, next stripe also 3 ways, next stripe also 3 ways, next stripe also 3 ways, and you get your answer, right? So I hope everyone is understanding what I'm trying to establish here, right? So the thing that I'm trying to establish is you have to go with the question in a structured manner. Start with the structural manner, draw the diagram in case it is needed, and start from one point, and that is going to lead you to next points, right? So now we are going to make it more structured. Let's see what is that. So in how many ways 5 prizes can be given to 5 girls such that 1 girl gets 1 prize, right? So this is what we have to do. There are 5 prizes. Let me say the prizes are 1, 2, 3, 4 and 5, and then there are 5 girls, A, B, C, D and E. These are the 5 girls. Now we have to distribute the 5 prizes to 5 girls. Now what do we do is, now over here we are distributing the prizes rather than girls coming and taking their prizes. So now we are distributing the prizes. Now what do we have to do is draw the number of slots of number of prizes, right? So first you have to distribute the first prize. So in how many ways can you distribute the first prize? You can either give it to girl A, or to girl B, to girl C, or girl D, or girl E. So there are 5 ways in which you can distribute the first prize. Now let's suppose girl A gets the first prize. Now in how many ways can you distribute the second prize? Because each girl has to get 1 prize, girl A cannot get more than 1 prize. So similarly 4 prizes here, for 3 prizes here, then 2 prizes here and 1 prizes here. So our answer is nothing but, if we calculate, it is nothing but 5 factorial. This is equal to 5 factorial. So I hope you are understanding, right? I'm trying to build something here. This is a very simple question. 5 prizes to be distributed among 5 students. So first prize can be given to any 5 of the girls. Second prize can be given to any 4 of the girls. Third prize can be given to any 3 of the girls, and so on, right? So let's move forward. So in how many ways can 5 boys stand in a row? So this, how would you do this question? Now this is again a similar kind of question, right? So there are 5 positions, right? First position, second position, third position, fourth position, fifth position. Now they're about to stand in a row. So in how many ways can a boy come on the first position? 5 ways, because there are 5 boys, right? So first position can be assigned to any of the 5 boys. Second position can be assigned to any of the 4 boys, any of the 3 boys, any of the 2 boys, any of the 1 boys. Yes, the answer is 5 factorial, right? Now let's see the next question. The next question is, in how many ways can 5 boys sit on 5 chairs? Which is a similar kind of question, guys. The question is same, as just the wording that is going a bit different. So again the answer is 5 factorial. So what I'm trying to do here, why I am a little bit fast here, it's because if you want to arrange n objects in n places, the answer is always going to be n factorial. You want to give 3 prizes to 3 girls such that each girl gets 1 prize, 3 factorial. You want to make 5 boys stand in a row, 5 factorial. 6 girls stand in a line, 6 factorial. So if you want to arrange n objects in n places, then the answer is always going to be n factorial, right? So I hope everyone is understanding. Now let's go ahead and build on what we have learned here, right? Okay, so Preeti is asking us a question. Okay, what if there are some conditions in the question? Good question, Preeti. So if there are conditions in the question, you must satisfy the conditions first. Now let's see this question. In how many ways 5 prizes can be given to 5 girls such that each girl gets 1 prize? And if first prize cannot be given to girl A or B. So I hope everyone is understanding this question. This question is pretty simple. Now, as Preeti asked us the question that first prize, what if there are conditions in the question, and I answered as you have to satisfy the conditions first and then go about with the question. So these are 5 prizes to be given. Prize number 1, 2, 3, 4 and 5, and these are the 5 girls which are there, right? Okay, now what is the condition? First prize cannot be given to girl A or B. Now let's give the first prize. Now first prize cannot be given to girl A and it cannot be given to girl B. So how many number of ways are there to give the first prize? Yes, there are 3 number of ways in which I can distribute the first prize. It can be distributed to either C, either D or either E. Right? Now let's go ahead and solve the next one. Now let's suppose any one of them gets the first prize. Let's suppose E gets the first prize. Now we have 4 prizes left and 4 girls left. So that would be distributed in 4 factorial ways. You understood it, right? 4 girls, 4 prizes, 4 factorial. So whenever there is a condition, what do you need to do is you need to satisfy the condition first. So if you satisfy the condition first, and then in the end you'll be left with the simple question: 4 prizes, 4 girls, right? So I hope everyone is understanding. This is we are building on it, so that's why it must be looking simple for you, right? Okay, all right. Preeti has another question. What if there are 2 conditions? Good question, very good question, because you would be getting questions in which there are more than 2 conditions. So what should we do? So there are sometimes certain number of conditions, certain types of conditions that are there in the question, right? So let me go ahead and explain you those types of conditions first. So there are 2 types of conditions. The first are positive conditions and the second type of conditions are negative conditions. So what is the difference between them? The positive conditions are the conditions relating to must be or should be, stuff like that, right? Let's suppose if 5 boys wants to sit on 5 chairs and I say boy A wants to sit on chair number 1. So this is what kind of condition? This is a positive condition, right? So if boy A wants to sit on the first chair, okay, that is a positive condition. If he does not want to sit on the first chair, this is a negative condition, right? So if he does not want to sit on the first chair, then it is a negative condition. So I hope everyone is understanding what I'm trying to establish here. So there are 2 types of conditions. Now this must be coming into your mind, which condition to satisfy first. So whether to satisfy the positive condition first or whether to satisfy the negative condition first. So now let's say this is, there are 5 chairs. A wants to sit on either second or third chair and B does not want to sit on fourth, or I'm sorry, it's fourth or fifth chair. Sorry about that. So there are 5 chairs. A wants to sit on either second or third chair and B does not want to sit on fourth or fifth chair. So let's see this way. Let us satisfy the positive condition first here, and in another scenario let us satisfy the negative condition first and see which one is giving us a more efficient answer, right? Let's see which one is more efficient. So let's satisfy the negative condition first. Now A wants to sit on either second or third chair, and B does not want to sit on fourth or fifth chair, right? So let's see that. Now these are 5 chairs: chair number 1, chair number 2, chair number 3, chair number 4, chair number 5. Now B does not want to sit on any of these chairs. Now let's suppose B sits on this second chair, right? Now if B sits on the second chair, then A has only one choice left, which is wrong. A is supposed to have two choices because he wants to sit either on second or B has only one choice left, which is this. So A wants to sit either on second or third chair, which means that which is wrong actually, because we are supposed to give A two choices, and we are satisfying B, but in the end we are forcing A to sit on the third chair. I hope you're understanding, right? So in this, if we satisfy the positive condition first, and then there are 5 chairs, so if we satisfy the positive condition first, and then boy A wants to sit on either second or third chair, so make him sit on any of these chairs. Okay, so we're making him sit on the second chair, right? And now B does not want to sit on fourth and fifth chair, which is fine. We won't allow him to sit on fourth and fifth chair, and he has another options to choose. So whenever you're satisfying a condition, never satisfy the negative condition first. Always satisfy the positive condition first. Always satisfy the positive condition first, and then satisfy the negative condition. So I hope you're understanding. Once you do this, you can't do a question wrong. You can't do a question wrong. It will be very, very simple for you. So let's go ahead and move forward, right? Okay, in how many ways 5 prizes can be given to 5 girls such that each girl gets 1 prize? If first prize cannot be given to A or B, and second prize must be given to girl C, right? So now there are 5 prizes, right? So I hope you're understanding the question, because we are just revolving around the same question once again. So these are 5 prizes and these are 5 girls, right? So now 5 prizes have to be distributed among 5 girls, right? Such that each girl gets 1 prize. Now what kind of conditions are there? First prize cannot be given to girl A or B. So this is a negative condition. It cannot be given B. Second prize must be given to girl C. So according to the question, we should be satisfying the positive conditions first. So these are the 5 prizes to be given away. So in how many ways can you give the second prize? Second prize can only be given to girl C. So there is only one way to give the second prize. You cannot give a second prize in any other way, right? So that means second prize is solved. Now let's satisfy the negative conditions. Now first prize cannot be given to girl A or B. Now first prize cannot be given to A or B. Now how many ways are there to give the first prize? Now first prize has already been given to girl A. This prize also has already been given to girl should not be given to girl B, and this prize has been given to girl C. So that means first prize there are only 2 options left. So I hope everyone is understanding. We cannot give first prize to A or B. C has already been given to second. Second prize has already been given to girl C. So now we are left with only 2 options, girl D and E, right? So now what? Now is there any condition left? No, there is no condition left. There are 3 girls, 3 prizes, which can be given in 3 factorial ways. So this is our answer, right? So I hope everyone is understanding what I did here. I just solved this. I just went with the question. I satisfied the positive conditions first. I satisfied the negative conditions first, and then I satisfied. Then there was no condition left. The same number of chairs, the same number of girls. That is the factorial, right? So I hope everyone is understanding the question. Okay, so now let's see this question once again. In how many ways 5 girls can sit on 5 chairs if girl A doesn't want to sit on first or second chair and girl B wants to sit in third or fourth chair? So once again, it's a similar kind of question. So these are the 5 chairs, right? And these are the 5 girls. So these are the 5 chairs and these are the 5 girls. So Now let's see the condition. Girl A doesn't want to sit on first or second chair. So now girl A doesn't want to sit, so it's a negative condition. Girl B wants to sit, that means it's a positive condition. So what do? We satisfy the positive condition first. Now girl B wants to sit on third or fourth chair. Now let's satisfy girl B's condition first. Now how many ways can you make girl B sit? She can either sit on the third chair or she can either sit on the fourth chair. So there are two ways in which girl B can sit. Now let's suppose she sits on the third chair. So third chair is already gone, right? Now girl A does not want to sit on first or second chair. Now girl A does not want to sit on the first chair. She does not want to sit on the second chair. Third chair has already been taken by girl C, that girl B. That means there are only two places left for girl A to sit, right? And now once again there are three chairs left and there are three girls left, which can be solved in 3 factorial ways. So this is our answer, right? So I hope everyone is understanding what I'm trying to do here. Let me just take a quick recap. There are 5 chairs, 5 girls, right? So first we satisfy the positive condition. Girl B wants to sit on third or fourth chair. So let her sit that. Make her happy. Let girl B sit on third or fourth chair. So we give her a choice, third or fourth. 2 ways to do that. She sits on the third. Alright, fine, move on. Now girl A does not want to sit on first or second chair. Girl A does not want to sit on first or on second. Third has already been taken. That means there are 2 choices left for girl A. Now there are 3 girls left, 3 chairs left, so that means the answer would be 3 factorial into 4, right? So I hope everyone is understanding this. We're going in a structured manner, that's why it must be looking very simple for you, right? Okay, now let's see this question. Okay, now this is again a difficult question, a cat question in fact, right? So there are 6 tasks and 6 persons. Task 1 cannot be assigned to either to person 1 or person 2. Task 2 must be assigned to either to person 3 or 4. Every person is assigned 1 task. How many ways this assignment can be done, right? So there is task 1, task 2, task 3, task 4, task 5 and task 6, right? And then there are 6 people, 1 2 3 4 5 6. So these 6 tasks have to be assigned, right? So since we are assigning the tasks, so we would be giving away the tasks rather than people coming and choosing their tasks, right? So task 1 cannot be, so it's a negative condition, right? Task 2 must be, so it's a positive condition. Now let's satisfy the positive condition first. Task 2 must be assigned either to person 3 or to person 4. So task 2 must be assigned either to person 3 or person 4. So how many ways are there to assign task 2? There are 2 ways. It can be either assigned to person 3 or to person 4. So that means, let's suppose task 3 is assigned to person 3. Now let's move on. Now he's saying task 1 cannot be assigned to person 1 or person 2. Now this task 1 cannot be assigned to person 1. It cannot be assigned to person 2. Task 3 has already been assigned to person 3. So that means there are 3 ways left to assign the task 1, right? So I hope everyone is understanding, right? So now how many tasks are left? There are 4 tasks left. And how many people are left? There are 4 people left. No condition, 4 factorial, right? So I hope everyone is understanding. So even if we calculate that, that is 6 times 1 into 2 into 3 into 4, right? So this is the definition of 4 factorial. So that is 12 and 72 and 144, right? So I hope everyone is understanding what I'm trying to establish here. Now this is a CAT question, so I hope you're seeing it. The toughest test in the nation has such simple questions. Now the questions are not that simple, but what happens is if you go with a structured way, if you plan the question accordingly, if you develop some habits, some good habits, just the way I did here, just the way I wrote the number of tasks, I wrote the number of people, then I draw the number of slots, and I drew the number of slots, and then I did did the question in a structured manner, you'll be able to do that pretty easily, right? So let's go ahead and move forward. Oh god, someone is really bored. He's saying, oh my god, how many more conditions? Okay, hold on, there is one more to go. Fine, now let's see that. Now what if conditions collide? I'm amazed Preeti didn't ask me a question. What if conditions collide? Now if conditions collide, what do you mean by that? Now let me show you. There are 5 chairs. A wants to sit on either second or third chair, and B does not want to sit on first or second chair. So these are the 5 chairs. 1, 2, 3, 4, 5. So if we go by the question, we satisfy this wants to. Girl A wants to sit on first, second or third chair. Let's suppose girl A in one scenario sits on the second chair, right? Now if girl A sits on the second chair, how many choices does B has? Now B does not want to sit on first or second. A is already sat on second chair, so that means B has 3 choices left for him. Now what if A sits on the first chair? Sits on the third chair. He wants to sit on either second or third. Once we make him sit on second chair, now we make him sit on the third chair. Now if he sits on the third chair, now B is only left. Now he can't sit on 1, he can't sit on 2. 3 has already been taken by A. That means there are only 2 choices left for B. Now you see the conditions are colliding. The choice of A is changing the choice for B. So that means in this kind of questions we will make cases. So what we will do in this kind of questions, we have to make different cases and add those cases, right? Which was pretty much the same thing in the previous time, because since all the cases were the same, so we were multiplying by the number of the number of ways in which the cases would be made. But over here, since the cases are different, so we have to add the number of cases, right? So I hope everyone is understanding, right? Now this is not simple stuff, guys, right? This most probably you won't be able to if you don't understand the previous video, right? So let's go ahead and move forward. Okay, now let's see this question. Same kind of question. 5 girls wants to sit on 5 chairs. Girl A does not want to sit on first or second. Girl B wants to sit on second and third chair. Now if you see over here, the conditions are pretty much colliding, right? So these are the 5 girls. Girl number A, B, C, D, E, and this is 1, 2. These are those 5 chairs. 3, 4, and 5. Right, so these are the 5 chairs and these are the 5 girls. Now let's see. Now what do you do in such kind of questions? You make cases. You calculate the different cases for the positive one. Okay, now make B sit on the second chair. How many ways are there to make B sit on the second chair? Only one way, right? So you make B sit on the second chair. Okay, alright. Now let's suppose B has sat on the second chair. Now A does not want to sit on first or second chair. Now A over here cannot sit here. He cannot sit here. So he has these 3 choices left. So he has 3 choices left for him, right? Now left for her, I'm sorry. Now there are 3 girls left and 3 chairs left with no conditions, so 3 factorial. Now let's add another case. Now let's make girl B sit on the third chair. How many ways to do that? Just one way to do that. Yeah, want to make girl B sit on the on one chair, so one way to do that. Now let's see further. Now let's see how many choices does girl A has. Now B has already sat on the third chair, right? I'm sorry, yeah, B has already sat on the third chair. Now girl A does not want to sit on the first, she does not want to sit on the second. The third chair has already been taken. She is left with 2 choices. And now there are 3 girls left and 3 chairs left, which is nothing but can be solved with 3 factorial, right? So I hope everyone is understanding. So this is the way you solve the question. So this is nothing but 3 factorial into 2 plus 3 into 5. That is our answer. So I hope everyone is understanding. When the cases collide, you are supposed to make different cases, and you start with the positive case, because The positive case gives you in how many gives you the different number of cases, and you go about and you solve the question, right? Now let's make it more clear to you. Let's solve some questions on it, right, so that you understand it. Okay, now this is a typical kind of question. Fine. In how now whenever these kind of questions come, the cases are already there. You know that if I'm trying to make a 3-digit number, 0 can't come in the beginning. If I'm trying to make an even number, there's supposed to be some 2, 4, 6 or 0 at the end. So cases are already there. So in these kind of questions, cases are predefined, right? So you're supposed to know that. Fine. So in how many integers greater than, are you saying how many integers greater than 999 but less than 4000, right? So that means from 1000 to 3999. So how many such integers can be formed using these numbers if the repetition of digits is allowed, right? So repetition of digits is allowed. So this has to be a 4-digit number, right? Because you're forming a 4-digit number. Had been there been a 3-digit number as well and a 4-digit number as well, then there will be 2 cases, right? So it's a 4-digit number. Now let's start with this slot here. So in how many ways can you put numbers here? So 0 can't come here, because if 0 comes here, then this will become a 3-digit number, which we do not want. So 0 can't come here. Either 1 can come, either 2 can come, either 3 can come. Can 4 come? No, 4 can't come, because we're forming numbers from 1000 to 399. So only 1, 2 and 3 come here. So there are 3 ways to fill this slot, right? So I hope everyone is understanding. Now over here you can fill any of the 5 numbers. Fine. Over here you can fill any of the 5 numbers. Similarly here as well you can fill any of the 5 numbers. Here as well you can fill any of the 5 numbers. So because the numbers can be anything. It can be 3124 or 3444, since the repetition of digits is allowed. So your answer is nothing but 375, right? So I hope everyone is understanding, and this is a pretty simple scenario. You will be able to solve this question pretty easily. Now let's see. Now this is a CAT 2008 question, guys. So I hope you are understanding how the toughest test in the nation, the test even tougher than the GMAT, gives you some such simple questions. Fine. Okay, let's move forward. Let's see some more questions. 8 boys have to be seated in 8 chairs, number 1 to 8 in a row. In how many ways the seating can be done such that if a particular boy does not want to sit on the first 4 chairs and other boy wants to sit on either 7th or 8th chair? Now there are again 2 cases, right? He does not want to sit. It's a negative case. He wants to sit. That means it's a positive case. So what we'll do, we'll satisfy the positive case first. So let's say there are 8 boys. Let me name them like this: A, B, C, D, E, F, G, H, right? So 1, 2, 3, 4, 5, 6, 7, 8. 8 boys, and let's say these are the 8 chairs. So 8 boys and 8 chairs. Now let's satisfy the condition for the positive case. Now one boy, let's call A, let's call that guy A. He wants to sit on either 7th or 8th chair, and there is another boy who does not want to sit on the first 4 chairs. That means the cases are not colliding here, right? So he wants to sit, so let me make 8 slots. 1, 2, 3, 4, 5, 6, 7, 8, right? So this boy A wants to sit on either 7th or 8th chair. So he has 2 number of ways in which he can sit. Let's suppose he sits on the 8th chair. Now a particular boy, let's say B, does not want to sit on first 4 chairs. So if he does not want to sit on the first 4 chairs, he can either sit on the 5th, he can either sit on the 6th, he can either sit on the 7th chair. So 3 ways he has got to sit. Now is there any condition left? No, there is no condition left. No number of chairs are how many? There are 6 number of chairs left and 6 numbers of people left. So nothing but 6 factorial. So my answer is 6 into 6 factorial. So it looks an easy question once you go with a structured way. You satisfy the positive conditions first, then you satisfy the negative conditions first, and then you go about with the question. Fine. Okay, now let's see another question. Right now, 8 boys have to be seated in 8 chairs numbered 1 to 8 in a row. In how many ways the seating can be done such that if a particular boy does not want to sit on even numbered chair and another boy wants to sit at extremes? Now, if you see carefully, first of all you have to decide either whether the cases are colliding or not. Now let's see that. Let's see, these are the 5 chairs. 1 2 3 4 5 6 7 8. So these are the 5 chairs. 1 2 3 4 5 6 7 8. Now for the sake of saving time, let me say there are 2 boys, right, who have conditions A and B. A over here does not want to sit at even numbered chair, so he does not want to sit at even numbered chair, and another boy wants to sit at extremes. So he wants to sit at extremes. So how do we go about that? So let's satisfy the positive condition first. Now if let's suppose this guy over here, there are 2 extremes, 1 and 8, right? So if boy B sits on the first chair, then A has how many choices left? He can either sit on 2, he can either sit on 4, he can either sit on 6, he can either sit on 8. So he has 4 choices with him. But if boy B sits on the 8th chair, how many choices does A have left with it? A has just 3 choices, 2, 4 and 6. So that means the cases are colliding. If B sits on the first chair, A is left with 4 choices. If B sits on the 8th chair, A is left with 3 choices. Now using this, we can form out an equation. Now let us make set B on the first chair. How many number of ways to do that? 1 way, because we are making set B on the first chair. And then how many choices does A have now? 4 choices, right? Fine. Plus 6 boys left, 6 chairs left, 6 factorial would be the number of ways, right? Sorry, this is a multiply, I'm sorry. Let me do it that way, okay? Plus, this is a multiply because the same case is going on. Now we are coming to a different case. Let us make B sit on the 8th chair. One way to do that. A has only 3 choices left, 3 choices into 6 boys left, 6 chairs left, 6 factorial. So this is nothing but your answer is 6 factorial into 7, right? So I hope everyone understood. You know, this question is way too difficult if you don't know the exact structure to solve this question, right? So this can come in your GMAT examination, this can either come in your CAT examination. Yeah, for GRE, yeah, can come, but you know, the chances are pretty slim, right? So let's go ahead and move forward with that. Fine. So our answer is nothing but 7 into 6 factorial. Fine. So let's see this question. So in how many 4-digit numbers can be formed using the digits 2, 4, 5, 8 if the repetition of digits is allowed, right? So over here repetition of digit is allowed and 4-digit number. So this is a 4-digit number which can be formed, right? So 4-digit number has to be formed using this 2, 4, 5 and 8, and the repetition of digit is allowed means you can use these digit any number of times you want. So how many numbers can come here? Any 4 numbers? 2, 4, 5, 8, because a 4-digit number can contain anything. Over here any 4 numbers, over here any 4 numbers, over here any 4 answers. My answer is 256. Easy question, right? Why I put an easy question in between of these tough questions? Just to take your mind away from, you know, those tough scenarios, so for you to understand it pretty more clearly, right? So let's move forward. Okay, so how many 4-digit numbers can be formed using the digits exactly once, right? Now this is a different question. Exactly once means you cannot use them more than one time. So you're forming a 4-digit number, right? So that means 4 slots. So over here you can use any 4 of them because it's a 4-digit number. Now if one of them is used, that means you can't use that one more time, and that means your answer is nothing but 4 factorial, right? Easy question, right? Pretty simple stuff. Let's move forward. Okay, now how many 4-digit numbers can be formed using this digits if the repetition of digits is allowed, right? Now this is again a similar kind of question, but there is just one twist in that. The twist is that over here the condition is you can't use 0. If you use 0, the number will be a 3-digit number. So over here you can only use this 4, numbers, right? 1 2 5 6. Over here you can only use these 4 numbers. Now repetition of digits is allowed. That means you can use any 5 numbers here, you can use any 5 numbers here, you can use any 5 numbers here. So that means your answer is nothing but 125 times 4, which is equal to 500, right? So I hope everyone is understanding the level of difficulty that we've done in the previous just in the video. This is nothing at compared to that, right? Okay, let's move forward. So how many 4-digit numbers can be formed using the digits if the repetition of the digits is not allowed? So I've just taken the previous question just one step forward. Now over here, repetition of digits is not allowed. So again, 4 slots. Alright, now over here you can't use 0. Fine. So let's satisfy this first. You can use any 4 numbers out of here. Okay, now over here you can use 0, but you can't use the number that you've used there. So again 4 number of ways, right? Because let's suppose you give 1 to this number, you can't use 1 here because repetition is not allowed. Fine. Now how many numbers are left? So there were 5 numbers, 2 numbers have gone, 3 numbers left, and over here 2 numbers left. So your answer is nothing but it's 3 times 2 times 4 times 4, which is 16 into 6, that is 96, right? So I hope everyone is understanding this question. It's an easy question, but you have to be careful. Fine. Okay, how many 4-digit even numbers can be formed using these digits if the repetition of digits is allowed? Right? Now over here, repetition of digits is allowed. Whenever this is given, our answer becomes our solution becomes a little bit easy, right? So repetition of digits is allowed. Now there is a condition on 2 cases. Over here 0 can't come, but over here only 0, 2 and 4 can come, right? So over here you can fill only 3 numbers, because since you're forming even numbers, right? So over here only 0, 2, 4 and come. Over here 0 can't come, so you can fill in any of the 4 numbers. Over here you can fill any of the 5 numbers, any of the 5 numbers, since repetition of digits is allowed, right? So your answer is nothing but 300. So I hope everyone is understanding what I'm trying to establish here. It's a pretty easy question. Let's go ahead and move forward. Fine. Okay. So now let's take the previous question to a next level, right? How many 4-digit even numbers can be formed using this digits such that we should not be using numbers more than once? So that means the repetition of digits is not allowed, right? So let's try solving this. Now since the repetition of digits is not allowed, we have to see whether the cases are colliding or not. So over here you can use 0, 2 and 4. Over here you can't use 0, right? Now let's suppose, let me assume if I use 0 here, right? Let me call this a slot number 1, slot number 2, slot number 3 and slot number 4. If in slot number 4 I give 0, then how many ways I can fill the slot number 1? If I give it 0 to it, I can fill 1, 2, 4 and 5. That means there are 4 ways. Fine. If give I4, this is slot number, right? And these are number of ways. So if I give any of them, any of 2 or 4 to slot number 4, then how many ways will slot number 1 have? Now over here, slot number 1 can have only 3 numbers. Why? Because one of the numbers from 2 and 4 have been given to slot number 4. That means slot number 1 will be left with only 3 choices rather than 4 choices. So you're seeing a difference of scenarios. That means the cases are colliding. Now in the previous questions, the colliding of cases was pretty clear to you right in front of you, 1 and 2, 2 and 3. But over here the questions is different, but we're using the same concept here. The cases are colliding. Now let's use this to solve our question. Now let's give 0 to slot number 4. How many number of ways to do that? 1 way to do that, right? Now if we give 0 to slot number 4, how many ways will slot number 1 has? 4 ways, right? So now how many digits are left? We have already distributed 2 digits. That means 3 digits are left and 2 slots are left. So any 3 to this one, any 2 to this one, right? Plus let's give 2 or 4 to slot number 4. How many ways to do that? 2 ways to do that. Similarly, how many choices does slot number 1 has? 3 choices, right? Again, 2 choices left, 3 digits left. So 3 into 2. Right? So this becomes pretty simple if you solve it this way. So if you solve it, it's 4 times 3, 12 plus 24. 24 plus 3 into 3, 9. 9 4s are 36. So 24 plus 36, that means it's equal to 60, right? So we got ourselves an answer. So if you see, if you don't follow the structural manner in this question, there is no way going forward, right? So you have to go in a structured way, solve the positive, see whether the cases are colliding. If the cases are colliding, start with the positive case. Once you start with the positive case, see what all cases are becoming, and draw this flow chart, because this is very important. Once you draw this flow chart, from this you're able to come through this, and from this you get your answer, right? Okay, thank you. Okay, so if you have understood all the concept, so what should be your next step? Your next step should be practice. So this is we have just done regarding the cases, the number of cases that it should take care of. So we have only covered the number of cases. So you should practice on that. Once you practice, you will be able to understand it with more clarity and with more depth, right? So you can watch this video as many times you want. You can even download it in case you need, right? So this was about the video. Thank you very much for the video. This is my email address where you can send me your valuable feedback. So in the coming videos, we'll be doing some combination problems, permutation problems, wherein there are different number of cases, different scenarios, but we'll be building on our first video. So I would recommend you to watch this first video and then go towards the other videos, right? There will be about more videos to come on permutation and combinations. So thank you very much, and see you next video.